Problem 11 on page 6 involves using Dalton's law of partial pressure. Let's first review the concept of Dalton's law of partial pressure before digging in on the problem. If we have a gas, say made up of these little blue dots, they create pressure by bouncing around and ricocheting off the sides of the container. The pressure created by this particular gas comes from only the collisions of the blue dot particles bumping into the sides of the container. So the blue dots would have some pressure associated with them, some pressure of blue dot. If there's another gas in the container giving us a mixture, this gas, our green triangle gas, will have collisions with the sides of the container, and we'll get some pressure that come from only the collisions of the green triangle. So we'd have some pressure associated with the collisions of the green triangle gas. Each of these pressures, the blue dot pressure and the green triangle in the mixture, are referred to as partial pressures. If we were to add together the blue dot and the green triangle, it would give us a pressure total inside the container, coming from all of the collisions against the sides. With a third gas in the container, gas X, the red X will also make its own collisions with the sides of the container, creating pressure coming from only gas X. Adding all of these pressures together would give us a pressure total that we have in the container, resulting from the sum total of all the different collisions against the sides of the container. If we examine the container, we can see it contains 10 particles. That's our total number of particles of gas. 6 out of those 10 particles are blue dots. This would be what we would call our fraction of the blue dot gas in the mixture. It's 6/10. If 6/10 of the particles are blue dots, then 6/10 or 60% of the total pressure will come from the collisions resulting from only the blue dot gas. Counting the particles, we see that 3 out of the 10 total particles are the green triangles. This would mean that 3/10 of the total pressure comes from the green triangle collisions, or 30% of the total pressure that we have would be resulting from the green triangle collisions. You can see that 1 out of 10 of the particles are the red X gas particles, so 1/10, which is the fraction of the particles that's just red X, 1/10 of the pressure, or 10%, would come from the red X. Adding together all the different pressures, we come up with 100%, which would be our total pressure in the container. In our problem, we're given the information in terms of moles. We have 1 mole of He atoms, 2 moles of hydrogen, 2 moles of nitrogen, and 3 moles of carbon dioxide. We can use this to get the mole fraction of each gas, and the mole fraction would be the same as the fraction of the total particles in the container that come from just that one particular gas. Adding together all the moles, we see that we have 8 moles total gas in this container. We can now find the mole fraction of each gas, which would be the same as the fraction of the total pressure that comes from that gas. For example, our mole fraction of He atoms is 1/8, in that 1 mole of the total gas is helium, and 8 moles is the total amount of gas. So the mole fraction of helium atoms in the container is 1/8. Similarly, the mole fraction of hydrogen would then be 2/8. The mole fraction of nitrogen would be 2/8 also. The carbon dioxide would be 3/8 for the mole fraction. To find then, say, the partial pressure, or the pressure coming from only the collisions of the helium atoms with the sides of the container, we can take the mole fraction of helium, which is 1/8, and multiply that by the total pressure, which we're given as 4 atmospheres. Multiplying this together gives us the fraction of the pressure, or the partial pressure, coming from only the helium atom collisions with the sides of the container. We find this, that the pressure coming from just the helium, or the partial pressure of helium, would be 0.50 atmospheres. We can repeat the process with the other gases using the mole fraction of each other gas to get their partial pressure as well. For example, for hydrogen, because its mole fraction is 2/8, or 2 particles out of the 8 total are hydrogen molecules. To get the pressure coming from only the hydrogen molecule collisions, 2/8 times 4.0, the total pressure, would give us a partial pressure of 1 atmosphere coming from the hydrogen. Repeating the process for the other gases, we find that our nitrogen also has a partial pressure of 1 atmosphere, and our pressure of carbon dioxide has a partial pressure of 1.50 atmospheres. Adding together all the partial pressures should give us the same total pressure we were provided of 4 atmospheres. Adding together the pressure of helium, hydrogen, nitrogen, and carbon dioxide gives us a total pressure of 4.0 atmospheres. So we found our partial pressure of each gas, and it does match up with what we have for our total pressure in the container.